Okay, in this video we're going to go over sample exam 2. This exam focus is pointers, loops, and arrays, mostly pointers. Alright, so let's start with number 1. Write the function prototype for a function called average age. So you already recognize that this is a function prototype. That's important to realize this is a function prototype. And the name of it is average age. It takes 4 arguments. 3 of the arguments are integers, and the 4th argument is a pointer to a double. The function will calculate the average of the first 3 values and store the result in the value at the 4th argument. Now this extra information here is not really important for writing the prototype, except if you were going to be putting the comments above it. So the function prototype is called average age. And it takes 4 arguments, so it takes 3 integers and a double pointer. And it does say that it calculates, but it stores the result in the value at the last argument, so it would have a void return type. Question number 2. Write a function definition for a function called letter grade. So this is not a function prototype, this is a definition. The name of the function is letter grade. It takes 2 double arguments, grade 1, grade 2, and a pointer to a character. So it takes 2 double arguments, double grade 1, double grade 2, and a character pointer to letter pointer. Char letter pointer. Okay, and this it's going to be storing the result at the value at letter pointer, so it is a void return type. We have an opening curly brace, and one hint to look at if it returns something. So here when it says that it will store in the value at and store in the value at, that does not say the word return. But if it did say the word return, you would have to possibly also return something, which would be a different type of return type. All right, so this is returning, but it's returning by reference. So now we just need to do the average. So we can calculate the average equals grade 1 plus grade 2 divided by 2.0. So then we're going to have a value for average, and if it's 90 or above, it will store a capital E, between 70 and 90, and 70 or below. So I would start with if average is greater than or equal to 90, then I'm going to take the value at letter PTR equals capital E, else if AVG is less than or equal to 70, then the value at letter pointer equals U, else the value at letter pointer equals S. All right, so that is question number 2. Question number 3. Write the function definition for a function called larger that takes 4 arguments. All right, so the function is called larger. And I got to have room here. It's going to take 4 arguments. The function should store the value of the larger of the 3 first values, argument values, into the value at the 4th, which is a pointer. So once again, this is like the other test. It doesn't say what data type. I'm going to choose integer. So I'm going to have integer x, so I have room, integer y, and integer z, and integer value at large pointer. So what I'm going to do here is I'm going to find which of these is the largest, x, y, or z, and store that value at the value at large pointer. So since I'm going to store the result in the value at my fourth argument, I'm going to have a void return type. So what I'm going to do now is I'm just going to say the value at large pointer equals x. So I'm going to set the value at large pointer to be x, and then I'm going to test y and z to see if they are larger. So I'm going to say if y is greater than the value at large pointer, then the value at large pointer equals y. If z is greater than the value at large pointer, then the value at large pointer equals z. So the best way to do this is to practice some values. So let's try the values 10, 10, and 6. So here we're going to have, so x is 10, y is 10, and z is 6. So here we take the value at large pointer would equal 10. Then you're going to say, is 10 greater than 10? No, it's not. Is 6 greater than 10? No, it's not. So when this function is done, the value at large pointer has a 10. Now let's try a different value. Let's try the values 6, 7, and 8. So if we start out, the value at large pointer is 6. Then we test, is 7 greater than 6? Yes, it is. So the value at large pointer would then be 7. Then you test, is 8 greater than 7? Yes, it is. And then the value at large pointer would be 8. So when this function is done running, the value at large pointer is going to store the largest value. Question 4. Write a set of statements that will search through an array called fruit. If a letter P or P is found, in uppercase or lowercase p, increase the value of an integer papaya by 1. So basically what we need to do is we need to search through an array called fruit. Now the only problem here is we don't know the size of fruit, so I'm going to add here that assume the variable count, and I will proofread questions, contains the number of characters in the array. Contains the number of characters in the array. So we have a variable called count, and the name of the array is called fruit. So now we're going to have to search through our array. So I'm going to declare an integer I. This is my iterator to go through the array, and then I'm just going to have a loop for I equals 0, I less than count. This is the basic array loop, I plus plus. And then we just put conditions inside of our loop. So we say if fruit of I equals P, or fruit of I equals lowercase p. So we're testing to see if the character, it's going to go character by character through this array called fruit, and if it finds a P or a P, then we are going to add one to papaya. So we're going to do papaya plus plus. Else if fruit of I equals equals, and we're checking now for a G, or fruit of I equals lowercase g. Then, so if we go through the array, so say the array has a bunch of letters in it like this, has a T, has an X, has a P, has a G, has a P, etc. So just to remind you that the count for this would be 0, 1, 2, 3. That's not a 3. 3 and 4. So the count for this would be 5 because there's 5 elements in it. So we'd start when I is 0 and I is less than count, and we're going to compare each one. This would be fruit of 0, fruit of 1, fruit of 2, fruit of 3. And if we find it, we're going to update these variables. So if we find a G, then we're going to add 1 to guava. And then if you find any other letter, you're just going to add 1 to banana. Bananas. And since it doesn't say to write a function definition, then all we need to do is write the series of statements and the loop that's going to go through this array. Let's do one more question for this video. Question number 5. Write a loop that will add up all the elements in an integer array and store the result in a variable called total. So right now we know that this also doesn't write a function definition, but we know that we're going to need a total. It's an integer array. So we know that our total is going to have to be initialized to 0 because it's going to store a sum. We do not have the name of the array, so we can call the array array. And we're going to assume that there are values in the array, and we're going to have a variable called count that has the number of filled cells in the array. So it's the same loop for going through an array. We're just going to go for I equals 0, I less than count, I plus plus. So we're going to go through the array and add all of the elements in the array and store that at total. So this would just be total equals total plus array of I. So I didn't give you the name of an array, so you can assume that you could name the array whatever you want to name it. So I'm just going to name it AR of I. So I have my total. It starts at 0. I go to my first element, which is array at index 0, add that together, and store that result in total. Then I go add 1, make sure I'm not at the end, and continue to add all the elements in the array. In the next video, I will do the last few questions.